Now we're going to talk about the reactions involving carbocations. First example is Wagner-Meerwein rearrangement. When alcohol containing more than two alkyl or aryl group on beta carbon are treated with acid, the product is formed, which is generally a rearranged product. Rather than the simple substitution or elimination product, the reaction is called as Wagner-Meerwein rearrangement. Newly generated carbocation is stabilized generally by loss of proton and less often by nucleophilic substitution or loss of some other positive group. Mechanism involves rearrangement of carbocation intermediate. This reaction is showing the mechanism for rearrangement. In the first step, it is given acidic medium, which would result in the dehydration of the product. And after that, migration takes place. An alkyl group attacks on the carbocation formed, and then a new carbocation forms. After that, proton is removed from the product and results in the formation of an olefinic bond. The earliest example of Wagner-Meerwein rearrangement was noticed in bicyclic terpenes. We have this bicyclic terpene, which is camphene as a result of Wagner-Meerwein rearrangement from isoborneol. Isoborneol removes the OH and forms a rearranged product, camphene. Another reaction is shown here. We have an alkyl halide which results in the formation of an alkene, or we have a secondary alcohol, camphenyl, which results in the formation of xanthine. In these reactions, double bond is formed according to Zaitsev rule. Leaving group in this reaction can only be hydroxyl or other leaving groups like chloride, bromide, which renders the carbocationic character of a carbon atom. Direction of rearrangement is usually from tertiary to secondary and secondary to primary. These are interesting examples where a series of rearrangement occurs simultaneously. One example is shown below, involves a terpene 3 beta predlanol. This compound on treating with the acid, another compound is formed with 7 successive 1,2 hydrogen shifts. Following is the explanation of those shifts, all 7 shifts. This is the example, and you're going to do it yourself. You have to do it in 7 steps, 7 to 8 steps, where we have all 2 successive 7 1 2 shifts. There are few other examples as well, and you are going to do these as your homework. You can click screenshot these examples and you can clearly do. These reactions take place due to thermodynamic stability of adamantane, diamantane, similar diamond molecules formed as a result of their rearrangements.